accelerated computing and AI are the most consequential technologies of our time. Modern computing started 60 years ago with the IBM System 360. The basic principles of its general-purpose computing architecture still govern today's computer industry. For nearly a decade, as the performance scaling of general-purpose processing has slowed, while computing demand continued, an exponentially growing performance-to-demand deficit has built up. If unchecked, this computing energy and cost inflation will stifle every industry. NVIDIA's accelerated computing has stepped in to the breach to meet the exponentially growing computing deficit. After 2 decades of work to reinvent the entire computing stack, NVIDIA accelerated computing has created a path forward at just the right time. NVIDIA accelerated computing has been described as a time machine for scientists to see the future, an instrument of discovery for the Da Vinci's and Einsteins of our time. From NVIDIA accelerated computing emerged generative AI. The result of over a decade and billions of dollars of investment, NVIDIA has made possible for the first time the production of our most valuable resource, intelligence. Like the AC generation plants invented by Nikola Tesla, NVIDIA's supercomputers are AI generation plants, or AI factories. We've started a new industrial revolution to mass produce digital intelligence. To seize this generational opportunity, companies and countries around the world are building NVIDIA-powered AI factories to process, refine, and manufacture intelligence from data. Intelligence in the form of digital tokens is a new kind of commodity, a new product, and it will create new revenue opportunities for the world's $100 trillion of industries. For the computer industry, generative AI represents a fundamental shift. Every layer of the computing stack is being reinvented. Where we once wrote software programs to execute explicit instructions, now we prompt large language models with our intentions. Computers are now intention-driven rather than instruction-driven. Tell a computer what you want, and it will figure out how to accomplish this goal. A complete reinvention of our industry, from how computers are designed, to how software is developed, to what software can do, will expand the horizons of every industry. A new industrial revolution has begun. Soon, every industry will be transformed. The historic nature of this moment is evident in our numbers. For FY24, revenue was up 126% to a record $60.9 billion. GAAP diluted earnings per share pre-split was $11.93, up 586% from a year ago. Demand for Hopper architecture products remains strong, and Blackwell, its successor, has been broadly adopted by the industry. By customer demand, ecosystem adoption, and bookings, the Blackwell architecture platform will likely be the most successful product in our history, and even of the entire computer history. Full-year gaming revenue rose 15% to $10.4 billion on strong demand for our GeForce RTX GPU. Full-year revenue for professional visualization rose 1% to $1.6 billion, and automotive full-year revenue rose 21% to $1.1 billion. NVIDIA accelerated computing has reached a tipping point and achieved a virtuous cycle. The significant CUDA installed base attracts developers and applications, which attract resellers reaching customers, which expands the installed base to attract more developers. CUDA, our parallel computing model, sits at the heart. It offers developers an unparalleled toolkit with over 300 libraries, 600 AI models, numerous SDKs, and supports 3,700 GPU-accelerated applications. This has resulted in a rich ecosystem that spans more than 5 million developers and 40,000 companies and thousands of generative AI companies building on NVIDIA. Accelerated computing is incredibly fast. but not quick to adopt. It has taken NVIDIA over 20 years to reach the CUDA tipping point. Applications must be rewritten to suit the new architecture and complex algorithms embedded in our CUDA libraries. Here are some examples of the hundreds of CUDA libraries. cuDNN, our renowned deep learning library, provides optimized kernels that accelerates neural network computations. Ariel, our CUDA engine for 5G radio access networks, is paving the way for a software-defined and AI-driven telecom industry. cuLitho addresses the computational challenges in lithography, the critical stage of chip manufacturing. Accelerated computing is sweeping across healthcare as digital biology and generative AI revolutionize drug discovery, surgery, medical imaging, wearable devices to patient care. Our partners include Amgen, Genentech, Johnson & Johnson MedTech, Medtronic, and hundreds of startups transforming healthcare into one of the world's largest tech industries. Just one example, our Parabricks CUDA library streamlines gene sequencing alignment and variant calling, offering the highest throughput in gene sequencing. In climate science, NVIDIA CoreDiff powers Earth-2, a digital twin that emulates Earth's weather and climate systems. CoreDiff is NVIDIA's generative AI model that predicts weather patterns 12 times higher in resolution, from 25 kilometer to 2 kilometer, and 3,000 times more energy efficiently than traditional physical simulation methods. Accelerated computing is sustainable computing. Every application that can be accelerated should be going forward. CUDA libraries activate NVIDIA accelerated computing for new application domains and open new markets and growth opportunities for our partner ecosystem. The world's $1 trillion of data centers should be modernized with accelerated computing. This year, we launched some of the most important products in our history. This is Blackwell. It starts with the most advanced GPU, designed for trillion parameter scale generative AI, and our fifth generation NVLink, which connects up to 576 Blackwell GPUs into one super GPU, up from just 8 Hopper GPUs. And compared to previous generation Hopper, Blackwell can train large language models with only a quarter of the GPUs and a quarter of the energy, showcasing a 25 times reduction in cost of ownership and energy consumption when inferencing frontier large language models. NVIDIA's offering starts with the most advanced GPU, but an AI factory is much more, combining Blackwell GPUs, NVLink, Grace CPUs, Quantum and Spectrum-X switches, and a rich ecosystem of software, systems, and data center partners. The Blackwell platform will be adopted by every major cloud service provider, server maker, and leading AI companies, including Amazon, Google, Meta, Microsoft, OpenAI, Tesla, and xAI. PC users have always been able to get the software they needed quickly and easily. Now, we're introducing a new way to distribute AI models. We call this new capability NVIDIA Inference Microservices, or NIMs. NIMs deliver enterprise-grade, optimized generative AI that runs on CUDA everywhere, from the cloud to on-prem data centers to RTX AI PCs, through our expansive network of ecosystem partners. NIMs integrate CUDA libraries, optimized inference engines, industry standard APIs, and AI model support into containers for straightforward deployment. These containerized pre-trained AI-in-a-box microservices enable enterprises across all industries to evolve into AI-driven companies. Adobe, Cadence, CrowdStrike, Getty Images, SAP, ServiceNow, Shutterstock, and others were among the first to access NIMs. More than 250 technology and platform providers are embedding NIMs into their services. And in healthcare, NIMs are already powering foundation models in drug discovery, medical imaging, and genomics. The next wave of AI is set to automate the $50 trillion in heavy industries. Soon, robotics factories will orchestrate robots that build products that are robotic. We developed Omniverse, a revolutionary virtual world simulation platform where the physical and digital world converge for developers to create robotic systems. Within Omniverse, industrial companies design, integrate, simulate, and operate digital twins of robotic systems, like factories, robots, and products. Omniverse is pioneering an open standard, open universal scene description format to seamlessly integrate industry-leading tools from design to manufacturing, allowing companies to create comprehensive digital twins that optimize the entire production life cycle. Self-driving cars are kind of a robot. The automotive industry has been an early adopter of NVIDIA Omniverse as it seeks to digitalize its entire workflow, from design to build, simulation, and operation, and even experience its factories and cars virtually. The new era of manufacturing is coming. Thousands of new and established companies are building robots and robotic systems. These companies will have two factories, one to build the physical robots, and another, an AI factory, to manufacture the intelligence that drives them. Generative AI and robotics are opening new growth opportunities, as well as drive a new level of productivity for the $50 trillion manufacturing industries. The next industrial revolution has begun. AI factories are producing a revolutionary commodity, tokens of digital intelligence. These AI factories are setting the stage for generative AI to become a multi-trillion-dollar industry and transform every industry. And the rise of sovereign AI in countries like Japan, Canada, and France, among many others, is a testament to the universal recognition of the importance of developing one's own AI capabilities, adapted for each nation's language and culture. Just 12 years after AlexNet, which was trained on two NVIDIA GTX 580 GPUs, stunned the computing world and ignited the Big Bang of modern AI. We are now beginning to realize the immense transformative potential before us. No one knew how far deep learning would take us. No one knew how far it would scale. I want to take this opportunity to thank the many researchers and scientists and developers, ecosystem partners, customers, and employees who dedicated themselves to explore what was a $0 billion market with us. We've reinvented NVIDIA, the computer industry, and very likely the world.
Thanks, Jensen. The time is 9:23 a.m., and the polls are now closed. The preliminary report of the Inspector of Elections covering the proposals presented at this meeting is as follows. First, each of the 12 director nominees on the ballot has been elected to serve until our 2025 annual meeting and until his or her successor is elected or appointed. Proposal 2, to approve the fiscal 2024 compensation of our named executive officers as disclosed in our proxy statement, has been approved. Proposal 3, to ratify PwC as NVIDIA's independent registered public accounting firm for fiscal 2025, has been approved. Proposal 4, to approve a stockholder proposal to replace the supermajority voting provisions in our charter and bylaws with a simple majority voting standard, has been approved. A full tally of the votes will be published in a Form 8-K, which we expect to file with the SEC within 4 business days. That concludes the formal portion of today's annual meeting, and I now declare the official portion of the meeting adjourned. I'll turn it over to Simona for stockholder questions.
Thanks, Tim. We'll now move to Q&A. We grouped together duplicative questions that we received to streamline the discussion. For our first question, Jensen, can you discuss NVIDIA's strategy for maintaining its competitive edge? What are your thoughts on the threat of other players in the industry developing competitive products?
Over a decade ago, we envisioned a new opportunity and dove into deep learning, systematically reinventing everything: the GPUs, interconnects, the systems, the networking, and of course, the software. We invested billions pushing into the unknown, extending the frontier of computing technology. Thousands of engineers have worked for a decade on deep learning, advancing and scaling without knowing how far we could take the technology. We transformed our company end to end to become a full stack, data center scale, AI systems and platform company. Today, we continue to push the frontiers of accelerated computing and AI. Our competitive advantage is our expertise, scale, and velocity to create the most advanced and end-to-end optimized AI computing systems, create new markets for them, and attract the world's developers while delivering extraordinary value to our customers. NVIDIA offers customers the lowest total cost of ownership through exceptional performance delivered by innovations at every layer of the stack, from chips to systems to software and algorithms. And the NVIDIA platform is broadly available through every major cloud provider and computer maker, creating a large and attractive install base for developers and customers, which makes our platform more valuable to our customers. NVIDIA has achieved a virtuous cycle.
For our next question, what are NVIDIA's plans for quantum computing development?
Practical quantum computing is still a couple of decades away, and when it arrives, computing algorithms will be a combination of accelerated and quantum approaches. NVIDIA CUDA Quantum is a platform for quantum computing and algorithm researchers to solve challenges on the road to useful quantum computing. We're partnering with the entire ecosystem, from the development of quantum algorithms, the design of higher fidelity qubits, the development of novel error correction techniques, to the calibration and optimal control of quantum device. NVIDIA's CUDA Quantum is an essential platform for the quantum computing community. Though no one knows which qubit technology will end up in useful quantum computers, NVIDIA's role in powering them is certain. NVIDIA is not building a quantum computer. We're building the platform essential for all quantum computers.
Thank you. Our next question is, what is the company's diversification strategy, particularly into the pharmaceutical industry?
NVIDIA is an accelerated computing platform company. We address multiple industries, from healthcare to automotive, manufacturing, financial services, energy, retail, gaming, and many others. Through a combination of our hardware systems and domain-specific software stacks, and a rich ecosystem of partners and developers. AI has sparked the next industrial revolution. It will transform every industry. Innovation in healthcare, drug discovery in particular, will be supercharged by generative AI. For the first time, we can represent and understand the meaning of the two things that describe drugs: biology and chemistry in a computer. This is paving the way for rise of computer-aided drug discovery. We should help the pharmaceutical industry become more efficient and effective in finding drugs for specific diseases and even specific people someday. We have built many enabling components, including our BioNeMo generative AI platform for drug discovery and our Parabricks software for genomics to make computer-aided drug discovery possible. And we're working with leaders in the field from Amgen to Genentech to Recursion, all of whom are already making rapid progress on the NVIDIA platform. Healthcare, automotive, and digital manufacturing are among the largest vertical industries we serve, with the highest potential for the impact that we make and the size of the opportunity. But the NVIDIA computing platform can support all $100 trillion worth of vertical industries worldwide, and we expect that to lead to increased diversification in the types of workloads and customers we serve.
Next, could you talk about our strategy to address the current semiconductor supply chain challenges? How does NVIDIA ensure a stable supply of semiconductor customers?
NVIDIA has the expertise and scale to develop a resilient supply chain. We will continue pursuing flexibility and redundancy in our supply chain, evaluating and quantifying multiple suppliers for components and processes that we use to build our products. In addition, we have strong relationships with our suppliers, and we may enter into long-term agreements to ensure supply and prepay for manufacturing or other key capacities.
What is NVIDIA doing to ensure that artificial intelligence has proper guardrails?
NVIDIA is actively shaping AI safety and ethics. We are members of safety initiatives in the US, EU, and UK. We are at the forefront of standard-setting bodies like the IEEE and the Content Authenticity Initiative, crafting guidelines that will govern the AI landscape for generations to come. Our partnerships with state and federal agencies ensure that we together are thoughtfully and collaboratively addressing challenges like content safety, model risk mitigation, and data privacy protection. We have also developed and released trustworthy AI technologies, including NeMo Guardrails, an open source tool for language models that allow developers and companies to control or prohibit prompts and outputs. We lead the industry in research and development of active safety computing systems and digital twin simulation platforms to ensure the safe functioning of robotic systems.
Thank you. Can you talk about the company's approach to corporate sustainability matters, including diversity and climate change?
Diversity and inclusion enhance innovation and empower our workforce. We want to attract people who want to do their life's work at NVIDIA and tackle the world's toughest challenges, and are committed to enhancing diversity in our company. Attracting and developing employees with diverse backgrounds and experiences is key to unlocking our full potential in creating groundbreaking products. NVIDIA is at the forefront of energy-efficient accelerated computing. General-purpose computing performance scaling has slowed. Customers are turning to NVIDIA-pioneered accelerated computing as the path to sustainable and cost-effective innovation. NVIDIA is modernizing the world's trillion-dollar data center industry and enabling applications to create remarkable new efficiencies and save incredible amounts of energy in every industry. Accelerated computing is sustainable computing.
Thank you, Jensen.